Next, we shall be testing another hypothesis when the sample size is small. Here we shall be making use of the t-test statistic when the sample size is less than 30, and that is condition for being for the sample size being small, with the degree of freedom of n minus 1. A case study. Suppose that we want to test on the basis of a random sample of size n equals to 5, that is, the sample size is less than 30, whether or not the average fat content of a certain kind of ice cream exceeds 12%. What can we do about the null hypothesis? Mu equals to 12% at 1% significant level. If the sample has a mean of 12.7% and the standard deviation S is 0.38%. Here you can see that the sample size is less than 30 and the population mean is given to be 12 and the sample mean is given to be 12.7. So obviously the sample mean is greater than the population mean here, and the sample standard deviation is given at 0.38%. So the appropriate test statistic to be used is T. So let us go by the procedure of hypothesis testing. So the first thing is for us to set the null hypothesis to be mu equals to 12% and alternative to be mu greater than 12%. Of course, this is given from that sample size of 12.7. So that is why the mean in the alternative is greater than 12%. So alpha is 1%. This is given as part of the instruction. The degree of freedom is n minus 1, which is 5 minus 1 equals to 4. So the appropriate test statistic to be used is the T, student T distribution test statistic, which is given here. Hence, substitute for those necessary parameters in the test statistic and you obtain the calculated value to be 4.12. From the statistical table, where you have the student distribution, you obtain the tabulated value at 1% significant level with 4 as degree of freedom to be 3.747. The decision is that since the calculated value 4.12 is greater than the tabulated value 3.747, then we shall reject the null hypothesis. Hence, we shall conclude that the contents of the given kind of ice cream exceed 12% at 1% significant level. Another hypothesis testing is for us to compare two population means when the sample size is large, that is, small letter n is greater than or equals to 30. And in this case, we shall be making use of the Z statistic test, but with more than one sample mean and standard deviation. So let us take an example. Given in the table here, the amount used to buy food are in thousands of naira. Use the 5% significant level to test the null hypothesis that the mean of these two populations given in the table are equal against the alternative that they are not equal. And in the table, we have been given that for the first population, the sample size is 120, the sample mean is 82.7, and the population standard deviation is 2.5. In the second population, we have been given that the corresponding sample size is 150, the sample mean is 61.8, and the corresponding standard deviation is 2.62. Following the procedure of hypothesis testing, the null hypothesis has been set to be mu1 equals to mu2, that is the population means for the two populations are equal, and alternatively, they are not equal. The appropriate parameters have been given here for the first population and for the second population. The significant level is 5%. So the appropriate test statistic is given as Z equals to, at the numerator we have the difference between the sample means of the two populations, and at the denominator we have the square root of the standard, the variance of the first population divided by the sample size from the first population plus the variance of the second population divided by the sample size from the second population. When you substitute into the appropriate statistics, then you have the calculated value of Z to be 2.89. From the normal distribution table from the statistical table, you will obtain that the tabulated values of Z from the table, tabulated value is 0.9989. And so here we shall conclude, since the calculated value is greater than the tabulated value, that is 2.89 greater than 0.9989, then we shall reject the null hypothesis as our decision and conclude that there is significant difference between the two average heights of adult females in the given communities. Another condition of hypothesis testing is to test for two populations and compare the means of these two populations when the sample size is less than 30, that is small. Here we shall be making use of the statistical tests. Yeah, so the statistic is given as this in this equation, where the numerator is the difference between the two sample means from the two populations, and the denominator is the square root of SP square. SP square is the pooled variance from the two populations, multiplied by bracket open 1 divided by the sample size from the first sample, that's supposed to be n 1 subscript 1, plus 1 divided by n subscript 2, which is the sample size for the second sample. So the pool variance is obtained as this. The numerator is bracket open sample size from the first sample minus 1 multiplied by the corresponding variance of the sample, plus brackets open sample size of the second sample minus 2 multiplied by the corresponding variance of the second sample divided by the degree of freedom, that is the denominator, the degree of freedom, which is the n1 plus n2 minus 2. Taking a case study, the following random samples are amounts used by two states in Nigeria to provide health facilities, measure the millions of naira for 5 months. So we have for state 1 and for state 2, which are given respectively here. Use 5% significant level to test whether the difference between the means of these two samples is significant. So here we can see that the sample size is less than 30 and we have two populations, samples of two populations. So we know the appropriate test statistics to use is the t-test statistics with the pool variance. So before we can use the test statistic, there is need for us to compute the necessary parameters. So the sample mean of the first sample is obtained by adding all the 5 values together divided by 5, which will give 8,160. For the second sample, you obtain the sample mean to be 7,730. The corresponding variance for the first sample is obtained from this formula, and that is obtained, that is the conventional formula for variance, is obtained as 63,450, and for the second sample the appropriate variance is obtained as 42,650. Now we can then go according to the procedure of hypothesis testing. So the null hypothesis, which is not showing on this slide here, we say that we mean the population means for the two populations are equal, while the alternative is they are not equal. So from the alternative, we know this is a two-tailed test. So we have been given in the instruction that the significant level is 5%. So we know that from the hypothesis testing procedure, and next we make use of the appropriate test statistic, which is the student t-test with pooled variance for two populations. So from the previous calculations we have made, we can then go ahead to substitute into the t-test statistic, and we shall obtain the value of the t-test statistic to be 2.9. Going to the distribution table, the statistic table for t-test or t-distribution at a degree of freedom of n1 plus n2 minus 2, that is 5 plus 5 minus 2, which is 8. Then we obtain the tabulated value to be 2.306. So since the calculated value is greater than the tabulated value, then we shall decide to reject the null hypothesis and conclude that the average amount spent on health facilities by these two states are significantly different. Dear learners, we have come to the end of this session. So far, so good. We have learned hypothesis testing. We have learned about non-hypothesis and alternative hypothesis. We have learned about the two types of error, type 1 and type 2 errors in hypothesis testing. We've learned about the procedures, laid down procedures, step-by-step procedures of hypothesis testing. We have also considered 4 conditions of hypothesis testing based on 4 different conditions. You can lay your hands on the exercise in the book materials with you. I will meet you in the next session. Thank you for listening.